Okay, the other day we looked at the distributive property, and today we're going to do the distributive property, but with dividing instead of multiplying. And that is where it is called factoring. Okay, we're looking at our factors, things that are being multiplied. What are the factors of the problem? And then we're going to divide them apart. So remember, simplifying and factoring are kind of like inverse processes. Okay. All right, so here's some review questions. Hopefully you remember it. If I need to factor this, I need to look at my two terms and decide what can I divide them both by. It has to be a common factor. So I know that I can divide this by 10, and I can also divide that by 10. But that is actually not the greatest common factor. That is the greatest number, but we also have x as a factor. So the greatest common factor is 10x. You have to include that variable. Okay, so that means that this actually gets divided out of our polynomial. So that 10x comes out here, and then you write what's left over. If you actually divided this by 10x and you cancel that out, you would be left with 2x plus, and if you divided that by 10x, you would have 5. Okay? So what we have here are two factors. This is a factor and this is a factor because they are being multiplied. It's the same idea as whenever you take 10. Remember, you do the factor tree and you say that's 2 times 5. That's what we're doing, but with our polynomials. All right, second one here. If we look at this, the greatest common factor is a 3r. That is the largest number and variables that we can divide those by, okay? So we are dividing all of these by 3r. So we're taking out the 3r, and we're going to write what's left. So this would be a 2 plus 5r minus 3s. Okay? And so that would be the factored form of that polynomial. All right, last one. If you look at this, we have two terms here that do not have any common factors. Now, 10 is not a prime number, but when you're looking at a 10 and a 3, there is not a common factor. So, if you remember, we call that a prime polynomial because the greatest common factor is a 1. Okay? All right, we also had a situation where the greatest common factor could have more than one term. So if you're looking at this entire expression, all right, this adding right here kind of creates two big terms here. Not really a term, but in this group, we have two factors, an a times an x plus 3. And this one is a 6 times an x plus 3. So they have a common factor of x plus 3 because they're both being multiplied by an x plus 3. So if I took that out, remember if I divided this by x plus 3, that's what we're doing, we would be left with a. And if I divide this by x plus 3, we're left with a 6. So whatever your greatest common factor is, has to come out. You divide that out, okay? And you write that. Don't forget to put that up front. Okay, so let's look at this one. We have 4 terms. If you look for a greatest common factor for all 4, it's not going to happen. Like these 3, this one, and this one, you could divide them all by 2, but that doesn't work for the 3b. This is where we did grouping. We looked at it and we said, okay, if I can't use all of them, I will group them 2 and 2. Okay, so these two, remember you're thinking divide, what can you divide them by? We can divide both of those by a 3b. So I'm going to take a 3b out of both of those terms. So this would be left as a 2a. plus 1. Okay, remember 3b divided by 3b is a 1. You have to have a term there. It's not a 0, it does not drop out. Now, put that plus in there because we're not multiplying here in the middle. These two have a common factor of a 2. So I can divide both of those by 2. Right? So this would be 2a plus 1. And now it looks like the last example where our greatest common factor has more than one term. Our greatest common factor is a 2a plus 1. So if I take that out of the problem, I would be left with a 3b and a plus 2 from here. Okay, now we have this factor. Remember, you're not done till you have groups that are being multiplied. Those are factors. All right, one more. This one says be careful. So as we go through, we're going to have to figure out what might be tricky about this one. If I look at all the terms together, I do not have a greatest common factor, but I can group these two and these two. So factor by grouping. Here, the greatest common factor is not x, it is x squared. You got to take out the most that you can. So the most that's in common, okay? So if I divide this by x squared, I have an x left, okay? Because remember there's 3 of them here, and you're gonna cancel 2 of them, so you still have an x, right? Here, if I divide by x squared, they both cancel, and I get a 1. Right? And on first glance, you might just divide this by a 2, but that would leave the minus. If you only cancel out the 2, the minus would still be on the x, and this would still be a plus 1 if you divide that by 2. And that does not give us common groups here. So that's where we're supposed to be careful. A lot of times, if that third term is negative, you actually want to divide by a negative factor, if you can. Kind of look at it and see if that would work. That would turn this positive, and that would turn this negative because you're divided by a negative 2. And now our 2 groups match. So we have an x minus 1 and an x squared minus 2. Those are our factors. Okay? So on that one, you just have to be careful. Sometimes you have to divide by negative, flip-flop your sign so it matches your first group. Okay, so good luck with practicing this. Make sure that you let me know if you have any questions.